In this video, we're going to talk a little bit more about inverses and how we can understand them. So we're going to start off by looking at some tables, because a table of values can help you understand inverse functions. So our first equation, f of x equals 2x plus 3, let's use the values -3, let's use -1, 1, +3, and 5. And the reason I'm picking these numbers, it's a little bit easier to see the relationship. So when we plug these in, we're going to have the following y values for those. So we're going to get a -3, a +1, a 5, a 9, and a 13. Now, when I plug in my inverse function into my equation, if I go to the numbers -3, 1, 5, 9, and 13, if I plug those in, the values that I'm going to get are going to be -3, -1, 1, 3, and 5. What do you notice about these table of values? You should notice that the y's of our original function became the x's of our inverse function, and that the x's of our original function became the y's of our inverse function, that those switched. Let's just take a quick peek at the formal definition of an inverse. So the definition of an inverse is that if you let f and g be two functions, such that f composed with g of x equals x for every x in the domain of g, and that g composed with f of x equals x for every x in the domain of f. Now, under these conditions, the function g is the inverse of the function f. And the function g is denoted by f raised to the -1, and we read that as f inverse. So the function f composed with the inverse of function f, or f inverse, equals x. And f inverse composed with f of x equals x. Now, this is important. The domain of f must be equal to the range of the inverse. Okay, so the domain of f must be equal to the range of the f inverse, right? And the range of f must be equal to the domain of f inverse. Now, if the function g is the inverse function of the function f, then it must also be true that the function f is the inverse function of the function g. And so it's for this reason that you can then say that the functions f and g are inverse functions of each other. So we're going to do an example, and we're going to find which of the functions is the inverse function of the function f of x equals 5 over x minus 2. Now, there's a couple ways to go about doing this, but I find that the easiest way is to take our function, take that f of x, and to find its inverse. So what we're going to do is we're going to write the function f of x equals 5 over x minus 2, and we're going to find its inverse. So the first thing we're going to do, the first step, is to replace our f of x with a y. Then we're going to switch the x and the y's places. So now we have x equals 5 over y minus 2. And now we're going to get the y by itself. Okay, we're going to get the y by itself. So the first thing that we're going to want to do is multiply both sides by y minus 2. That allows us to cross those off. So that's going to give us y minus 2 times x equals 5. So again, we're trying to get the y by itself. So we're going to divide both sides by x. And that's going to leave us with y minus 2 equals 5 over x. Then we're going to add 2 to both sides, leaving us with y equals 5 over x plus 2. And when we rewrite that in inverse notation, we get the inverse of f of x equals 5 over x plus 2. And now we simply need to look and see which equation does that match. Does it match our g of x, or does it match our h of x? And here we see that it matches our h of x. So it is the inverse function of 5 over x plus 2.